My goal is to become the place where parents and caregivers come to find childcare that works for them.
My goal is to build the largest university in the world.
My dream is to be the telemedicine provider for kids and families to stop generational trauma.
I want to change culture. I want to enable these gaming communities to become self-sufficient. That's the goal.
May I have your attention? Please welcome back TechCrunch Managing Editor, Matt Burns.
That's my boss. He's really happy for me. Hi, everyone. I'm Matt Burns. Thank you for joining us for the second session of Startup Battlefield. Earlier today, we saw a lot of really interesting startups that are developing technology in deep tech sectors, and today we're going to see even more. Let's recap a few things, though. TechCrunch had 3,200 companies apply for this Startup Battlefield class. We selected 200 of them, and you can see all of them downstairs. But out of the 200, we selected 20 to pitch on this stage. And over the next 2 days, or today and tomorrow, they're going to pitch on this stage. We have 5 companies in the morning and 5 in the afternoon. So let's get started on this second round. I'm going to bring out the judges real quick. I'm going to read their impressive bios, and then we'll bring the first company. So judges, come on out. You can clap for them. They're cool. Yeah. Yeah, that's Henry. He's really nice. Okay, first we have Morgan Beller. Morgan is a general partner at NFX and is co-founder of Libra and head of strategy for Novi, Facebook's digital wallet for the Libra payment system. She originally joined Facebook as part of the corporate development team in 2017, where she worked on defining Facebook's strategy around blockchain, cryptocurrency, and decentralized technology. Prior to Facebook, Morgan ran corporate development at Medium. Next, we have Mark Bhargava. Mark is the managing director at General Catalyst and part of their fintech crypto investment team. Mark focuses on early stage investing across both crypto and fintech, as well as building out the creative strategy. Additionally, he contributes to GC's expanding AI efforts. Prior to joining GC, Mark spent years as a founder-operator with an emphasis on new fintech, AI, and crypto technology. As an angel investor, Mark worked closely with founders on sales, distribution, and fundraising. Next, Preeta Choksi. Preeta is at Norwest Venture Partners and brings more than 20 years of corporate and business development experience to her role as a partner on Norwest Consumer Internet team. Prior to Norwest, Preeti spent 9 years at Facebook in executive roles in corporate development and business development. Before her time at Facebook, Preeti spent 6 years at Google in strategic partnership roles. Earlier in her career, she earned her startup chops and strategy and management roles at 2 fast growth companies, one which was acquired in 2001, and the other one went public in 1997. Next is Healy Cipher, Chief Operating Officer at Atomic. As COO, Healy oversees the daily operations of the 11-year-old venture studio to support founders and foster an inclusive culture where team members thrive. Driven by his entrepreneurial vision and Atomic's model of building companies in parallel, Healy co-founded BoomPop at Atomic in 2020, where he also serves as CEO and helps Fortune 500 companies create the next generation of workplace culture. And last but not least is Tess Hatch, partner at Bessemer Venture Partners. Tess is a vice president at Bessemer, fostering entrepreneurship of frontier technology, specifically the commercialization of space, drones, autonomous vehicles, and the future of agriculture and food technology. She wants to invest in technologies and people who believe as strongly as she does that frontier technology would develop solutions for societal problems. That is a lot. You guys do a lot of things. Thank you so much. All right. Well, with that said, let's bring out the first company. From Durham, North Carolina, we have Avalo. Presenting Brendan Collins and Mariano Alvarez. Come on out, guys.
I'm Brendan Collins, the co-founder and CEO of Avalo, where we use AI to make more climate-resilient crops.
I'm repping for her. If we're going to sustain humanity over the next 25 years, we're going to need to increase our agricultural output by 60%. That's 60% more food, more clothes, and more medicine. And at the same time, we're expecting a massive uptick in the number of climate-related crop failures. Hi, everybody. My name is Mariano Alvarez. I'm an evolutionary biologist and the Chief Science Officer at Avalo, where we're on a mission to accelerate the creation of new and productive crop varieties. So if you want to create a new crop variety, you have to start by understanding the genetic basis of the trait that you're trying to improve. Scientists normally start with methods like the genome-wide association study that you see up on the screen right now. If you're working on a simple trait like disease resistance or pest resistance, it might involve only one or two of these genes. But if you're working on something complex like time to harvest or drought resistance, it might involve thousands of these genes, which makes this process way more complicated. The genome-wide association studies are our current state of the art, but only about 14% of the things that they return are actually useful. And sometimes it's as low as 1%. And after you're done finding your target genes, it's at least 5 years and up to $100 million to produce even a simple genetically modified variety. Or you could run a traditional plant breeding program, which could take a decade or more. We have an urgent and unmet need to deliver new and resilient crop varieties to farmers, which is why we're seeing substantial investments and great economic outcomes for other companies in this space that are offering even incremental solutions. But until we figure out how to reduce the bottleneck in the discovery and the development process, we're just not going to meet the needs of billions of people in time. At Avalo, we drew our inspiration from natural selection, which, although it's incredibly slow, is actually really efficient in creating new varieties of crops that are able to survive in different conditions. Our core technology was based on some of my research at Duke University, where I fit statistical models to that long history of natural experimentation. In a collaboration with Squirrel Award-winning professor Cynthia Rudin, we realized that we could use techniques from interpretable machine learning to open up what would have otherwise been black box models. The result is a new discovery method that, instead of the 14% accuracy of GWAS, allows us to identify causal gene targets with 90% precision. We then used that knowledge to build an AI-enabled recommendation system that suggests which plant crosses might produce the traits that we're looking for. And it does that with only 1/100th of the data that's normally required. This level of accuracy and efficiency allows us to forecast plant outcomes before they even happen. And that lets us increase the process of discovery and development by up to 77%. So I know I'm making some big claims here on stage, so let me walk you through a series of experiments that we did to try to optimize the complex trait of time to harvest in Chinese broccoli. Time to harvest, by the way, is really tightly correlated with yield and with seasonality, so it's actually a really important trait for farmers. So we started by planting 300 different varieties of broccoli in our greenhouse in North Carolina. We then sequenced each and every one of their genomes, which resulted in like 2 terabytes of data. We then ingested all of that data into our discovery platform, and that set the stage for our recommendation system. Can we go to the demo? So in this recommendation system, our software allows us to simulate all of the possible crosses. So we select the experiment, and then we wait a second while the simulations load, and then we'll see all of our possible crosses on the screen. On the left-hand side, on the y-axis, is the time to harvest, or the time to maturity, and on the x-axis is bud size. And on the right-hand side, you can see all of the possible crosses that we could make. We could then sort that list and see which ones have the shortest time to harvest. We actually did that. We took the top 3 here, and then we made those crosses in real life. And then we planted them out in our greenhouse in North Carolina. The broccoli that you see here was actually our winner. It had the shortest time to harvest, from 45 days when we started to just 37 days when we were done. This allowed us to validate our process in just 1 breeding cycle, just using genes that already exist in nature. Beautiful broccoli. Thank you. Because we're able to achieve this new level of cost and time efficiency, we can actually work on any crop in the world. So even crops that were too complicated or too costly to work on are now economically feasible for us. And as a result, we're working with a number of pilot partners to get our technology into their existing breeding pipelines so that they can reap the time and cost advantages. But the real goal of our company is to make new seeds. And we're currently doing that with partners like Farmed Materials to create an alternative source of rubber, and with our own R&D pipeline to create sustainable sunflowers for cooking oil and drought-resistant cotton with better fiber quality. We're really lucky to be joined on this process by plant breeders, biologists, computational specialists, not just from top-tier academic institutions, but also from huge strategic agricultural companies, all of whom really believe in our mission to change the way that we grow crops. You know, when my best friend and I started this company a couple of years ago, we asked each other why we wanted to do this, why we wanted to start a company in agriculture. The answer for us is that there's no job we'd rather do, no problem we'd rather tackle, and no impact we'd rather have than this. If you believe that a more sustainable and resilient world is still possible, I urge you to send an email to one of the addresses on the screen and join us in planting the seeds for a greener tomorrow. Thank you so much.
Can you guys take a step over a little bit over there? Get in the light, yeah. And I got to know before we start, where in Michigan are you from? I'm from right here.
Okay, so my in-laws are from right here, which
That's a good.
it's beautiful.
Yeah, good beer down there.
Yeah,
Okay.
absolutely.
Go blue.
Yeah. That's
Yeah.
right. Preeti, you want to start with you?
Sure. I was curious on what are your sources for data as you go from customer to customer?
Yeah, that's a really good question. So when we work with partners, sometimes they have their own data sets, and that's great. That can plug into our existing pipelines. But what we realized is that most of the data is either not high enough quality to train our models or is locked behind big private companies. So we've actually gotten really good at generating our own data. We can do just 1 or 2 really efficient experiments in the field and then gather the data that we need to train our models. So we actually now have greenhouses and field sites and a lab, and we can do all of it in-house.
So when you say you can do 1 to 2 experiments, in the example that you used with the broccoli, you had 300 varietals.
Yes.
Would that count as 1 experiment or 300?
That is 1 experiment
Okay.
with 300 plants. Yeah.
Got it. Okay, thank you.
Yeah.
Tess?
Great presentation. Loved the show and tell and the decision on,
yeah,
on
thank
broccoli.
you.
Beautiful broccoli. Stealing your joke. Help me understand the relationship you're going to have with farmers. Right now, are they your customers, but eventually you're going to vertically integrate and compete with them, and how they feel about that?
That's a really good question. So they are our customers. So at the end of the day, farmers, when they buy a bag of seeds, they're paying for our product and from the R&D that we're able to put into that product. So our goal is to actually just create the intellectual property of the seed. Then we can work with distribution partners or other large agricultural companies to actually get them propagated and distributed so that farmers can actually plant them in our fields. But farmers' needs are obviously really important because they're the ones that are paying us at the end of the day.
And what are they using right now if they're not buying your seeds?
Yeah, that's a good question. So there's other seed companies, usually divvied up by different crops. And the larger companies are Bayer and Corteva and BASF, so big chemical companies. And then there are sometimes smaller integrated producers. So sometimes tomato companies will have both the processing plant and the seeds themselves. So it's kind of a complicated landscape, but we think that by starting with the seed, we can actually address a lot of different customers, regardless of how their resulting pipelines look.
Thanks.
Yeah.
Healy?
Hey, awesome presentation. I love this, by the way.
Thank you.
So I'm thinking of the Monsanto business model where they own the seed IP, and then basically if the crop produces seeds, like, sorry, that's not your seed, friend. That's still mine. And you resell them year after year.
Yep.
How does your business model compare contrast? And can you be a Monsanto killer, or do you sell to them?
Yeah, that's a really good question. So I think there's a lot of people working in this space that are offering different types of solutions, and we're a small company, so we want to make allies and not competitors. But I will say that there's a few different ways to protect the intellectual property of the seed, and a few different ways to get it out into the world. In our case, the types of seeds that we're producing are what are called hybrids, and so farmers can buy them year after year. They could save them, although their performance will go down over time. So farmers are actually incentivized directly to continue to buy new seeds, but if they don't, that's okay.
Why does performance go down?
Performance goes down because the way that the genomes are composed, sorry, this is a little bit in the weeds, but they're...
Pun intended.
Pun intended.
The alleles are heterozygous, so when the plant is crossing with each other, it can often result in a new outcome that is not what we intended in our lab. That's okay, but probably performance will go down if you continue to save your seeds year after year. And it's only by this sort of controlled process of bringing plants together that we can create the highest performance.
Got it.
We'll go to Mark and then Morgan.
Sure. How did you guys come up with the name Avalo? Where did that come from?
Yeah, I'll take that one. My mom's family is from India and from the Himalayas, and so we took the first part of the name from a Buddhist saint that is sort of popular in that region.
Gotcha. And then as a follow-up, what sort of AI technology do you use, and do you leverage OpenAI or Anthropic or Google? Like, what's the background to what you're building?
Yeah, that's a good question. So we, all of our AI, in particular the stuff that we developed, is proprietary to us. Our real secret sauce is the interpretability of the models, and so we can wrap any existing AI model in our methodology that allows us to open it up. So it's nice for us because there's a lot of people that are doing really amazing work in the AI space. We can just use their models and implement them in our system, but our ability to open them up is what allows this discovery and prediction process to proceed more efficiently. So we're sort of a layer on top, actually.
Gotcha.
Yeah.
I also love what you guys are up to. I love that like the physical demo worked and the software demo worked, and like that's not something we did. And the uniform of like this vintage.
Oh yeah, thank you.
So I also had the M word written down for Monsanto, but my novice question is, like I'm hearing your pitch. I'm like, yeah, that makes sense. Like there's a lot of people we need to eat. It's all going in the wrong direction. Like directionally, that all makes sense. But all of the big companies that you're speaking of and Monsanto like have to be thinking about this also. So just like help me understand, what part are you doing that like they're not doing?
Yeah, that's actually a really good question. So
Quickly,
usually in this space, like corn is king. And so all the other breeding programs only get the dredges of what is going into the corn program. So by not focusing on corn specifically, but going on that kind of tier right after of soy, other like million-acre broad acreage crops, there's huge opportunities to access those areas specifically.
I would buy the anti-big corn thesis. So I'm in on that alone.
Okay, thank you so much, everyone. Give them a round of applause.
Great.